No, I mean it's just like I just so just going to explain what we had at the challenge, what we did, and then what we think could be improved, like not necessarily just on the code, but on the ideas, on what could be done after that. Again, if anyone is just finding randomly this YouTube video, I'm not an expert on TerraFlow, so maybe what we did is completely wrong. What I say is completely wrong. But anyway, so team one, Nikhil and myself, we worked on challenge number 9, which is retrieving the underlying TAPI topology. I'm just going to do one quick slide on what is TAPI if people don't know. I think people from Adtran should be a little bit aware of that because that's what we're using for our optical controller. So it's mostly a thing from the optical side. Yes, so Transport API to retrieve the information of the optical device, the links and everything underneath. So we use the topology that is called OLS. I think the name is OLS. I don't know, OLS CTX. You can find that, I think, in Hackfest, the repository Hackfest, and then it's somewhere in the database, and the context is called mini OLS context or something like that. So it is in the repository. We use the same, and basically what you can find is all service interface points. So it's basically all the ports and input and output and everything. So you have all the information on that. If it's a fiber link or if it's something else, you can have way more complicated TAPI topology with OMS and OTS layers and all the different layers of the OTN stack. But you can also have other information such as the nodes themselves, so all the nodes that are in the topology and all the links below. So you can see links going from node 1 to node 3. So the problem. I think what we thought was a challenge is when you load that topology. So first you load just the context and the topology, and then when you load the JSON file, which is a TAPI context that you retrieve, that's what you see. You see one box, which is the OLS, and that's because the device, the structure of what you enter in this JSON file has a device that is named OLS, and then you just call the TAPI context. I should have shown that as well, but I have it later. But anyway, so then you see the device that is here, and you see a bunch of, so the address, the port, the settings, and all the endpoints. And then I think what we wanted is to know more about that topology, and not just that it's a topology, but what are the nodes that are in there and what are the links? Because you see the endpoint, you could kind of, I don't even know if you could guess, but you see the endpoint, so it would be nice to have on top of that all the devices and the name listed either in this configuration or in a slightly better way, which is, I think, more complicated, but I'll talk about that at the end. So first of all, what we try to do is just have, when you go to device and you go in this little eye icon, then you can see all the endpoint, but you can also see all the device and the links. So the first thing we did is running the mock TAPI server from Hackfest 1, which is just creating a server so you can request the TAPI topology from the TAPI server. So then we run it having that IP address and port. So then in TFS, when you just load that context or that JSON file, you specify the address, you specify the port, and then it will look through this port and this address and retrieve the TAPI context, and then you have all the nodes and all the endpoint that we showed before. So the second step is to actually implement the logic. So where would you find those nodes and those links? It's just a simple enough Python file where you just have to go through that kind of tree structure where so we go into topology, which is here, then we increment into the nodes, and then we get all the nodes and the UUID, and then we put that into device, which is what is supposed to be supported. And then same for the link, we increment through the links, we get the UUID, which is just a name. Then we increment to the node edge, and this is where you find the start and the destination. And then you create link, and then you add just all the data. So that should work. So we implement that somewhere in the code, and I wouldn't be able to tell you why. And then what's the result? It doesn't work. It doesn't work because I think so. The logic itself, I would say, it's correct. I mean, or it's very close to be correct. It's not that complicated to go through the tree anyway. But I think what's missing is the link between the TFS web UI or something, which is the controller itself, and then the call that is made in the function where we implement that. So I think that's why I was mostly asking about those resource key, because I know it goes through the resource key that we talked about at the beginning, but then I don't know what it does, and I don't know what it doesn't go through the rest of the topology and the links. So but anyway, it's a starting point. I think we're not that far at all of having it plotted, but then that's one step. And then what we were actually thinking is, well, I think I wouldn't put that into medium color for the challenge for someone who has never have any experience with that. But then it would be actually to be implemented it into the device themselves. So instead of having just one block, it would be nice to have the topology itself. I didn't say it, but the topology we use had 4 nodes, and I think 4 links. I would say, or 5, I don't know. So then it would be when you click on device, instead of just doing having one block, you have the 4 device. When you click on link, you have all the links. When you click on services, you have all the services. Because all those things, you can retrieve that from the TAPI context. But I think the big problem is the TAPI context tree is not the same as the TFS API kind of tree. So this device tree, which retrieves all the device and all the link, is not the same as the TAPI one. So it's slightly more complicated to retrieve that. But I think that's it. I hope that makes sense a little bit.
Yes, thank you very much, Julie, for the explanation.